In this video, I shall present another set of 7th grade mathematics exercises and problems taken from a 7th grade mathematics workbook. Test 2, exercise number 1, calculate. Point A, n equals 2a minus b. A is equal to minus 29 plus 35 times plus 6 times minus 5 minus 4 plus 6, which is equal to 6 times minus 30 plus 24, which is equal to 6 times minus 6, which is equal to minus 36. B is equal to minus 18 plus 24, which is equal to minus 2 times minus 14 plus minus 12 times plus 3, which is equal to 6 times 28 minus 36, which is equal to 6 times minus 8, which is equal to minus 48. In both A and B, we do the multiplications before the additions and subtractions, and notice that in a multiplication of two numbers with different signs, the product is negative, and in a multiplication of two numbers with the same sign, the product is positive. N is equal to 2 times minus 36 minus 48, which is equal to minus 72 plus 48, which is equal to minus 24. Point B, minus 9 plus 25 times minus 63 divided by minus 7 minus 63 plus 7 divided by minus 8 minus 48 divided by minus 8. We do the divisions before the additions and subtractions, and as in multiplication, the division of two numbers with the same sign has a positive result, and the division of two numbers with different signs has a negative result. So we have 16 times 9 minus 56 divided by minus 8 minus 6, which is equal to 16 times 9 minus 7 minus 6, which is equal to 16 times minus 4, which is equal to minus 64. Point C, minus 23 plus 29 times minus 7 times minus 8 plus 9 times minus 6 minus 45 divided by minus 9. Again, we do the multiplications and divisions before the additions and subtractions, and we also mind the signs of the result of the product of multiplications and divisions according to the signs of the two numbers. So we have 6 times 56 minus 54 minus 5, which is equal to 6 times 2 minus 5, which is equal to 6 times minus 3, which is equal to minus 18. Point D, minus 54 plus 2 to the power of 3 times 7, everything to the power of 2, minus 6 to the power of 3 divided by 2 to the power of 3 times 3 to the power of 2, plus minus 4 to the power of 3 plus 3 to the power of 2 times 7, everything to the power of 2, minus 3 to the power of 3, everything to the power of 2, divided by minus 3 to the power of 5. We raise the numbers to their powers first, then we do the divisions and multiplications, and lastly we do the additions and subtractions. So we have minus 54 plus 8 times 7, everything to the power of 2, minus 216 divided by 8 times 9, plus minus 64 plus 9 times 7 everything to the power of 2 minus 3 to the power of 6 divided by minus 3 to the power of 5. So we have minus 54 plus 8 times 7 everything to the power of 2 minus 216 divided by 8 times 9 plus minus 64 plus 9 times 7 everything to the power of 2 minus 3 to the power of 6 divided by minus 3 to the power of 5, which is equal to minus 54 plus 56 to the power of 2 minus 216 divided by 72 plus minus 64 plus 63 to the power of 2 minus 3. So we have 2 to the power of 2 minus 3 plus minus 1 to the power of 2 plus 3, which is equal to 4 plus 1, which is equal to 5. The same rules apply in point E as in point D. We do the powers first, then multiplications and divisions, and lastly additions and subtractions. Notice that minus 2 to the power of 2 is equal to minus 4 and not plus 4, because 2 is inside the parentheses and not everything is the power to the power of 2. Also notice that minus 2 to the power of 2 everything to the power of 3 is equal to minus 2 to the power of 6 because we multiplied the exponents. By doing the calculations, we obtain a result of minus 1. Exercise number 2. Determine the natural numbers n for which point A minus 4 to the power of n times plus 12 to the power of n equals minus 48 to the power of 3. Minus 4 to the power of n can be written as minus 2 to the power of 2, everything to the power of n. Plus 12 to the power of n can be written as 2 to the power of 2 times 3, everything to the power of n. And minus 48 to the power of 3 can be written as minus 2 to the power of 4 times 3, everything to the power of 3. So we have minus 2 to the power of 2n times 2 to the power of 2n times 3 to the power of n is equal to minus 2 to the power of 12 times 3 to the power of 3. Minus 2 to the power of 2n times 2 to the power of 2n is equal to minus 2 to the power of 4n times 3 to the power of n equals minus 2 to the power of 12 times 3 to the power of 3. From these we can infer that n is equal to 3 because 4n is equal to 12 and n is equal to 3. Point B. Plus 9 to the power of n times minus 5 to the power of n equals minus 45 to the power of 8. Plus 9 to the power of n can be written as 3 to the power of 2, everything to the power of n, times minus 5 to the power of n, and minus 45 to the power of 8 can be written as 3 to the power of 2 times 5, everything to the power of 8. We can eliminate the minus sign here because minus 45 is raised to a power which is an even number. So 3 to the power of 2n times minus 5 to the power of n equals 3 to the power of 16 times 5 to the power of 8. So n is equal to 8. Point C. Minus 7 to the power of 12 divided by minus 7 to the power of n equals minus 7 to the power of 5. When we divide two powers with the same base and different exponents, we keep the base and subtract the exponents. So we have 12 minus n equals 5. So n is 12 minus 5, so n is equal to 7. The same rule applies in point D as in point C. So we have 18 minus 3n equals 9, so n is equal to 3. Exercise number 3. Determine the integer numbers n for which point A, n to the power of 17 divided by n to the power of 10, everything divided by n to the power of 3 equals minus 9 to the power of 4. From the round brackets we have n to the power of 7 divided by n to the power of 3, which is equal to minus 9 to the power of 4. So n to the power of 4 equals minus 9 to the power of 4. So n can be plus or minus 9 because minus 9 is raised to a power which is an even number. So minus 9 to the power of 4 is equal to 9 to the power of 4. Point B. N to the power of 2 times n to the power of 3 is equal to minus 7 to the power of 5. We keep the base n and add the exponents together when we do the multiplication. So we have n to the power of 5 is equal to minus 7 to the power of 5. So n is equal to minus 7. Point C. Minus 7 to the power of 14 divided by minus 7 to the power of n is equal to minus 7 to the power of 9. When we do the division of two powers with the same base but different exponents, we keep the base and subtract the exponents one from another, the first from the second. So we have 14 minus n equals 9. So n is equal to 14 minus 9, which is equal to 5. This was the first part of test 2, presenting exercises 1, 2, and 3. Thank you for your attention. Goodbye.